in this example, we are asked to find the Taylor polynomial of degree n next to point A. So to do that, let's write down our general formula for a Taylor polynomial, which is going to be f of a plus f prime of a x minus a plus f double prime of a x minus a squared, and the further components of this formula up until the number that we want. So let's just start writing it down. P3 of x is going to be e of a. 8 is 8, so it's going to be e of 8, right? So e of 8 plus e prime of 8, basically e of 8 prime. This is what this component means, but e of 8 prime is actually just e of 8. So this is all we need to write, and then x minus 8 plus second derivative of e of 8 is also e of 8, and then x minus 8 squared, and plus, because it's a third degree polynomial, right? So this is 0 degree, this is first degree, this is second degree, and the third degree is just like that. It's just e of 8, but then x minus 8 cube, and we also have to divide this whole thing by 3 times 2 times 1, and this we also have to divide by 2 times 1, and this we have to divide by 1. So basically this is what the Taylor polynomial of e of x to the degree 3 looks like. Okay, so again, the same thing, just another formula. So let's start doing that. So first of all, we're going to need to find the derivatives. So the first derivative of this function, f prime of x, is going to be negative 1, 1 plus x, negative 2, which is going to be negative 1, 1 plus x to the power of 2. So the second derivative is going to be 2 over 1 plus x to the power of 3. The third derivative, let's compute this one. So the first derivative is this, then we just differentiated it and made it this, okay? And then the derivative of 2, 1 plus x cube. So this can be rewritten as 2, 1 plus x, negative 3. So the derivative of this is 2 negative 3, 1 plus x to the power of negative 4, which can be written as negative 6 over 1 plus x to the power of 4. Okay, so it's negative 6 over 1 plus x to the power of 4. And I'm just going to erase this. Okay. Now we can construct our polynomial. Okay, so P3 of x equals to f of a, which is 1 over 1 plus 3, plus f prime of a, which is this. We're just going to sub in sorry. So this is 1 plus 2, right? Because a is 2, a is not 3, a is 2. So then the next one is negative 1 over 1 plus 2 squared times x minus 2 over 2. So this is just according to the formula we saw in the previous example. The next one is this one. So we're going to add it and we're going to sub in our a for x. It's 2. This is over 1. So the next one is 2 over 1 plus 2 cube x minus 2 over 2. And then minus, this is this one, minus 6 over 1 plus 2 to the power of 4 times x minus 2 over 3 times 2. So this is what the polynomial looks like. Squared. So now they're asking us to find this polynomial. Again, the general formula is Pn of x equals to f of a plus f derivative of a, x minus a, plus f second derivative of a, x minus a squared over 2 plus f third derivative of a, x minus a cubed over 3 times 2 plus f fourth derivative of a, x minus a to the power of 4 over 4 times 3 times 2. So let's try doing that. Okay, so p4 of x is ln x squared and our x is 1 here. So that means that it's ln 1 squared. And ln 1 squared is 0. So we can write 0, but we can just leave it like that. So the derivative of ln is 1 over x. So the first derivative is 1 over x, and x is 1 in this example. So it's 1 over 1. And then x minus 1 plus. So we had ln of x. First derivative is 1 over x. Second derivative is, so if you differentiate 1 over x, you can get minus 1 over x squared, right? And so this is first derivative, second derivative. Third derivative is going to be, as you can see from here, it's going to be 2 over x to the power of 3, right? Because, why is that true? Because this can be rewritten as negative x to the power of minus 2, which if we would differentiate it, give us negative 2 x negative 3, which is 2 over x to the power of 3. Okay, let's start writing this down, and then if we need to differentiate some more, we're gonna do that. Okay, so second derivative of a is this. So minus 1 over x is 1 here, right? So 1 over 1 squared, x minus 1 squared over 2. This is our third derivative. I'm just going to leave it here. So then it's a plus 2 over, again, our x is 1 cube x minus 1 cube over 3 times 2, which is 6, right? Okay, and so the derivative of this is our final derivative. We need to find the derivative of this. So ddx of this is negative 6x to the power of negative 4, right? We can see that because this can be rewritten as 2x to the power of negative 3, which will give us negative 6x to the power of negative 4, which can be written as negative 6x to the power of 4. So this is our final derivative. So negative 6x to the power of 4. Again, our x here is 1. So 1 to the power of 4. I'm going to erase it. 1 to the power of 4. X minus 1 to the power of 4, according to this formula, over 4 times 3 times 2. And so to organize it a little bit, we're going to have 0 plus x minus 1, because this is just 1, it cancels out, minus 1 times this number. So x minus 1 squared over 2 plus this is going to cancel out to 3, which is going to give us x minus 1 cubed over 3 minus 6 and 6 are going to cancel. So it's going to give us x minus 1 to the power of 4 over 4. And here they ask, use the third degree Taylor polynomial to find this. Okay, this is quite straightforward. F of 1. So here we know that we are looking at these Taylor polynomials at the point a equals 1, right? Because we can just see this from here, because they're all centered at a equals 1. So f of 1 is just going to be the first number here, which means that it's going to be 5. F first derivative of 1 is going to be just this number here, according to the formula we saw earlier. F third derivative of 1, oh no, sorry. F first derivative of 1 is going to be 2, but f second derivative of 1 is going to be this number, but not just this number, because remember that in the formula is like this: f of a plus f derivative of a x minus a plus f second derivative of a x minus a squared over 2 plus f third derivative of a x minus a cubed over 3 times 2. Right, so this is actually not 3, because the formula had 2 right here, right? So the situation is like this. So there had to be some number x, let's call it number c, that multiplied by f second derivative of 1, which is what we're trying to find, and divided by 2. This number gave 3, right? So what is this number? So obviously we know that this number is 6. So 6 divided by 2 would give us 3 in this situation. So f second derivative of 1 equals to 6. And f third derivative of 1, again, same situation as we had before. X third derivative of a is divided by 6. So there had to be some number that would give us 1 here, right? So, and this number would actually also be 6, because actually this number would be 3, right? Because here we didn't have any denominator, but here we have a 2 in the denominator, so that would give us 3. So why would that give us 3? Well, if you look here, say now we have 1 here, but if we had 3 here, 3 and 3 would cancel, and we would have the same situation here, right? X minus 1 over 2, which is here, x minus a over